In this example, we will see how to minimize a logical expression of 5 variables using the kernel map. So we need a kernel map of 5 variables. We have 2 templates here. We will use one for the minimum sum of products and the other one for a minimum product of sums. The method is exactly the same than with 4 or 3 variables kernel map, but when the map is bigger, finding the adjacencies can be a bit difficult. So that's why the kernel map is a good method for functions up to 4 variables. For 5 variables it's possible, but it's a bit error prone. And for 6 variables is quite difficult and really not practical for more than 6 variables. But just as an example, we will see how to do it. So this is our function. Remember that in 5 variables kernel maps, we really have 2 4 variable maps. If we divide by the middle part here, these 2 kernel maps are mirrored because we sort the values as in the gray code. Okay, so we can build one by building one 4 variables map and another variable map in the opposite direction. It will be 0, 0, 0, 1, 1, 1, 1, 0, and so on. And now the adjacencies are in each half map on the left side and the right side. We have the same adjacencies that we have in a 4 variable. So this minterm 8 is adjacent with minterm 0 and 12 with 14 and so on. But because the map is done like that, we also have adjacencies if we imagine that we fold the map through the middle line here. So for example, this place is adjacent to this one. We can easily check because the only bit changing is this one here. This is 1 and 0. Okay, so this is minterm 0, 0, 1, 0, 0. This is 1, 0, 1, 0, 0. Okay, so this is adjacent with this one, this is adjacent with this one, and so on and so forth. So for example, if I have once here, this implicant here could be adjacent with this implicant here because they are symmetric. So I will have a implicant of order 2. We can signal it in the map, we can group it in the map doing something like this. Okay, we'll leave the group open here and open here, so we know we have to find the continuation on the other side of the map. Okay, the same way we may have something like this, for example. Okay, so this is one group. Okay, but still these 2 are still adjacent to these 2 as in a regular 4 variables map, so this could be another implicant. Okay, we could signal like this. So let's do the practical example that we have here with this particular function. Oh, let's delete all the marks. So here we have the index of the minterms in each place. Normally you should remember the index, you should know how to follow the map. You have to remember that it depends on how you sort variables, because this is the natural order for my variables. When I have defined a function, then it's minterm 0. Okay, and this is minterm 12 because 0, 1, 1, 0, 0 is number 12. Okay, if you sort the variables here in a different way, then your minterms will be in different places, so be careful with that. Normally people used to do it always in the same way, so you get used to some kind of sorting. I, for example, always start putting my variables here on the columns and then continue on the rows. So this is the typical sorting. So I'll copy the minterms here. So I have minterm 0. I'll change to my regular blue pen. We have minterm 0, minterm 1, 2, 4, 7, 8, 10, 15, 16, 17, 18, 20, 23, 24, 25, 26, 27, 28, 31. Okay, because I want to do the sum of product, I will not write the zeros to have a more clear map. Here I will do the product sum, so in this case I will be interested in putting the zeros, so I will complete the map now. I'll leave it for later. These are the zeros, 0, 0. So with this we will calculate the minimal sum of products. With this we will calculate minimum product sum. I'm checking that everything is correct. I think so. So great. Now, just the same method. I check all the possibilities, and you may start with any minterm like this one here. So I find adjacencies. This one is adjacent to this one. I have an implicant here. The possible candidates for these are, so I have this implicant here. Okay, the possible candidates are the one on the right, but it doesn't exist. The one on the left, okay, it does exist. So I have an adjacency here. The one on the left inside this map will be this one. This is another candidate for adjacencies. And the one on the bottom or on the top, in this case, it is the same. Okay. So these are all the possible adjacent terms to this one on this map and on the other side of the map. Okay. Note that this is not adjacent. Okay. In case of doubt, just check the value. I have 0, 0 here, 1, 1 here. Two different bits. The bits are different, so it's not adjacent. So the only adjacent term is this one here. So I will remove all these and mark the actual adjacent term like this. Okay. This is my first prime implicant. So these two, or this one as well, is adjacent to this one. I check this on the right, the one on the left. Here I have one on the left. The one on top is I don't have it. The one on the bottom I don't have it, but I have the one on the left. So this could be another adjacent term. Great. Still with this one here, I have one adjacent, another adjacent minterm here. So these and these are two adjacent terms. Okay, I'll use a different color. So this is adjacent to this. Okay, and these two I will try to find the adjacencies. This one and this is adjacent to this one and this one to this one. Okay, so this term here is adjacent to this term here. But I have to check with the map on the right, so I find that if I fold them up here, this is adjacent to this to this to this to this one. So these all four ones together are a term, okay? The adjacent term to this will be one on the right, this one and this one, but why we don't have it. Or the one on the bottom, this one, the one the bottom, this one, but we don't have it either. Okay, we should have this one together with this one. These two will be adjacent to these two and these two. And the one on the left I don't have either. Okay, so basically, and I think it's the first time I have found this term in a map, but basically these are these 8 ones, 4, 2, 3, 4, 5, 6, 7, 8. So I will mark them with my regular color as this together with this, together with this, together with this. So basically I mark the borders, okay? These continue here and this continues here. Whew, so great. Now I will continue following this method. So this one here, for example, has an adjacent term here. I don't have on top, bottom, right, but yes, I have one on the other side of the map. So these 4 form another prime implicant. Okay. More options. These 2 are adjacent to these 2, but this is already part of my big and quite dispersed prime implicant here. So this one, for example, is adjacent to this one. These 2 are adjacent to these 2 here. And that's all. So all these make another prime implicant, I think. And the same way, these 2 are adjacent to these 2. No one on the right, no one on the left, no on the other side of the half map. So this is another prime implicant. Okay. I have to say that I'm not convinced I'm going to do it. Okay, I don't have the solution. So it's done in real time. So I may miss some implicants. Okay, now I think it's all covered. This one here is adjacent to this one to this one, so it's another implicant. And we don't have the symmetric one or the top, so this is another implicant altogether. And maybe there are some ones that are still part of other implicants, but I think these are all the options. I think I've taken all the options already. Okay, but as you see, it's not easy to see all the options, and it's very easy to make mistakes. Okay, so I'm going to put names to my implicants. My big implicant will be number 1. Okay, this one that goes one side and the other side of the map will be number 2. These 2 with these 2 will be number 3. So I can keep track of all the implicants. This one in the 2 sides of the map will be number 4. So I have all these covered. This one that is in this side of the map will be number 5. Now, the vertical one will be number 6. The square here will be number 7. And I think it's done. It's 7 prime implicants, I guess. Okay. Now I can start checking if I need all of them, which are essential. So this prime implicant is essential. This is my number 1. Okay, this is essential. This prime implicant number 2 is also essential because of this term here. Number 4 is also essential. Great. Number 3 is also essential because of this one. This is the only implicant covering this one. Okay, number 4. Number 5 is this 4. Number 5 is this one and this one. I don't really know because these are already covered. This is not essential. I don't know if we will need to use it. This is number 4, number 5. So number 6 is the one here, the long one here, but there's no one that is covered only by that implicant, so it's not essential as well. And finally number 7 is this one. And I think, yeah, it's the drawing is not good, but okay, I think it's like this. So yes, it is essential to cover this. Okay, number 7. So I have to take all the implicants, number 1, 2, 3, 4, and 7. So now the question is, do I need to take 5 and 6? 5 and 6, let's see. All the ones in 5 are covered by already essentially prime implicants. Number 2 here. This one is by number 1 here. And this one is covered by number 1. Implicant number 1. And I'm in doubt about this one. This is covered by number 7, okay, which is essential as well. So I don't need to include number 5 in my expression. Now number 6, this one is already covered, this one and this one are already covered by prime implicant 7, okay, and this one is already covered by prime implicant 1 and maybe others, so I don't really need to take number 6 either. So to obtain the minimal sum of product expression for my function, I just need to take prime implicants 1, 2, 3, 4, and 7. So, what are the expressions? I just look at the values of the bits. In this case, this is when A may be 1, 0, or this is this 1, 2, 3, 4, 8 ones here. 1, 2, 3, 4, 5, 6, 7, 8. So A may be 0 or maybe 1. B is 0 here, 1 here, so B can also change value. C is 0 here, 0 here, 0 here, and 0 here. C is always 0, so this term is a C complement. I'll change to the regular color. Oh, sorry. Oops. It's F is C complement, and now these are all here or here. D changes value, E is 0, E complement. Okay, this is implicant number 1. Number 2 is this 4, which is B and C are 0 all the time, B complement, C complement, and D is 0, D complement. This is number 2. Number 3 is these 4 midterms, which is A changes, B is 0 all the time, which is B complemented, C changes, okay, D and E are 0, D complement, E complement. This is number 3. I also take number 4. It is 0, 1, 1, 1, so B changes, C is 1, C is 1, A changes, so this is C, D, and E. This was implicant number 4. Number 5 is 6, I don't need them. And finally number 7 is A is 1, B is 1, and E is 1. A, B, E, number 7. So this is the a minimal sum of products. Okay. Now, for a minimal product of sums, I just go in exactly the same way but using the zeros. Here is the middle of the map. Okay, I like to mark it, and this area here. So this one and this one are adjacent. Okay, I'll have to find someone on the bottom. We don't have it. On top, I have this one. So these two is an implicant. I don't have the one on the left, not the one on the right. So that's it. This is my first prime implicant of zeros. I will start numbering just from the beginning. That is a bit easier. Now let's go with some other zeros here. This 1 0 here don't have anything except on the left, and also on this part of the map. Okay, so if we take this one and this one, not on the top, not on the bottom, not in the middle, so this is a prime implicant, this one together with this one, but this is also another different prime implicant. This 0 here is adjacent to this 0 here, no one on the bottom, no one to the middle, no one on the outside, so this is another prime implicant. This is actually involved in many of them, because these together with this will make another prime implicant, okay, with not additional adjacencies, and these two make another prime implicant with not additional adjacencies. And these two have a symmetric here, okay? So these two together with these two. I forgot to number the implicants, so I'll start doing it. This one going to the far side will be number 2. This one in the middle will be number 3. This one here will be number 4. This one going inside the map will be number 5. This one going to the other side, number 6. And I have many small prime implicants. Number 6, and let's see. Okay, we have some others, like this one and this one. This is another prime implicant. I think it has not additional adjacencies. Great, would be number 7. And I think that's all. Okay, you can try finding anyone else, for example this one together with this one, but you find that this is already included in this big one. So now let's try to find which are the essential prime implicants. I looked at the isolated zeros, so this one is essential, okay? So number 1 is essential. Number 2 is this one together with this one. It's also essential because of this term. Great. Number 3 is the one in the middle. It's not essential because this is covered by more than one implicant. Number 4, the same thing. Number 5 is the same thing. Number 6 is essential. Okay, and number 7. Oh, I missed the number. Yes. Okay. Yeah. Number 7 is the one vertical here, and number 5. I'll try to put it a bit clearer. Number 5 is this one here. These are not essential. So now my expression I'll keep it in green color. Let's see if I need all of them. Okay, by using number 1 I will have this covered, this covered, this is covered. Using number 2, which is essential, I have this covered and this covered. Using number 3, 4, 5, number 6, we have this covered and this covered. And there are many many terms that I don't have covered yet. Oh yeah, I missed to signal this one. This is another prime implicant, 8, which is also essential. Okay, so we have all these also covered. So what the mean terms I don't have covered yet, all in this side are these one here, these 3 mean terms here. Okay, so what I have to do, what we have to do now, is trying to find a minimum set of the remaining prime implicants to cover all those mean terms. One prime implicant is not enough. Okay, I have 3 zeros here. I may have this one and this one, okay, or this one and this one. So now we should do an analysis of what are our options. Actually, the complete Quinn-McCluskey method has a step where you check all the possibilities using different tables, so you can select the minimum or the optimal or the one of the minimal solutions for these options. But normally, even with 5 variable maps, normally options are not that much. So we can easily see that we need to take at least 2 additional prime implicants. And the point is that our options are among implicants 3, 4, 5, and 7, and all of them are of order 1. So I must take the fewer the better, and also to take them of the biggest order possible. Okay, but these are all order 1, and there are many possibilities, all with this similar result. So I will simply take number 4, okay, to cover these 2 zeros here, and I will take number 7 to cover these remaining 0 here. Okay, so I'll use 1, 2, 1, 2, 6, 7, and 8. Okay, now the expression for these terms. These are sum terms. I'll start with number 1. Okay, this is 0 when B and C are 1, so I will have B and C complemented, because we need this term to be 0, so to have a 0 here I need to complement the literal. B and C complemented, and in this case we also have that E is 0, okay, the one that is constant, so just simply E without complement. Okay, this is the prime implicant number 1. The number 2 is this with the one on the other side. It is for B0 and C1. B is 0, C is 1, and D is 0 and E1. D0, E is 1. Okay, so the ones that need to be 0 are not complemented, the one that needs to be 1 are complemented. Number 2. Okay, let's go for number 3, 4, no, 5, 6. 6 is these extremes here. This is B and C are 0, B less C, and dne are 1, d complement, e complement. This is number 6. 2, 3, 4, 5, 6. Now we decided to take also number 4. Okay, I forgot about it. So I'll take now, this is A is 0, B is 1, D is 0, and E is 1. This is number 4. Now I have to take number 7 and number 8. Okay, I will continue in a following line. Okay, so this is an AND operation. Now I take number 7 is this one here. This is A0, B1, C0, and E is 1. This is term number 7. And finally term number 4. This one here is B is, this is C is 1. This is the one constant. C is 1. D is 1. And E is 0. This is term number 8. So all this expression is a minimal product of sum. Is not unique because there are other options with the similar result, okay, but this is one of the minimal. If I choose to a different option of implicants, the result is not much different because it will give terms of the same order. It will give terms of the same order, okay? And that's it. So yeah, you see that it's not very nice to do a 5 variables kernel map. So I hope you never have to do one, but you need to know how to do it. Thank you.